Yeah, so today I'm going to talk about the topic of engineering social concepts. And there are a couple of core questions that philosophers who work on concepts are investigating, including myself. So these questions include how do we represent categories, but also how are language, perception, and social cognition shaped by the way we represent categories. Now, if you're interested in these questions and working on them, you're likely also interested in the third question, which is how can we change and improve our category representations for the better? And needless to say, in this context here, projects of this type usually fall under the umbrella of conceptual engineering, where roughly conceptual engineering can be described as consisting of, first, the assessment of representational devices, second, the reflections on and proposals for how to improve representational devices, and efforts to implement the proposed improvements. I know in this context, it's probably not something I have to explicate, but I do it anyways. This is from a recent volume by paper by Kaplan and Plunkett. Now, many proposals for conceptual change, also called ameliorative proposals, have already been submitted, proposed in philosophy and elsewhere. So, for example, there's been an influential proposal by Noam Chomsky to treat language as denoting an internal, individual, intentional property of our psychology. This is sometimes also described as I language. Within philosophy, Haslanger has famously proposed to analyze women as people that are subordinated on the basis of observed or imagined reproductive features, arguing that this kind of treatment would lead to important social and political improvements if we change our theorizing in accordance with this kind of analysis. Similarly, McKinnon has proposed that we should treat pornography, again, for important theoretical purposes in legal contexts, as the sexually explicit subordination of women. Now, some of these proposals are unsurprisingly more controversial than others, but if the proposal in question is accepted, then we can imagine how changing the meaning of this theoretical vocabulary in relatively small, controlled communities, such as academic communities, seems relatively straightforward. So an example is, for example, the relative success of Chomsky's ameliorative proposal for language in academic linguistics, which now arguably is the dominant usage of that term within academic linguistic contexts. But this leaves open the question of how we can change ordinary concepts that really guide our categorization induction behavior in everyday life, how we enact changes in people's non-technical, non-controlled employment of their conceptual practices. And these kind of questions are the questions I'm interested here in this talk. The question of, can we engineer social concepts for the better in a way that really impacts people's day-to-day ordinary folk usage of the relevant concepts. Now, why do I focus on social concepts? Because these questions of how we can enact changes in people's non-technical ordinary concepts probably has specific significance with respect to social concepts, because what our concepts say, what our concepts about, for example, social groups look like, can have important normative and material consequences for the relevant group members. So again, with that in mind, the main question for today is, can we engineer ordinary social concepts and enact changes in ordinary deployments of those concepts? Now, this kind of question is a question of feasibility, because I want to know how conceptual engineering can be put into practice given contingent factors of our psychology, social environment, or history. And as Marjorie points out, thinking about the feasibility questions is an instance of non-idea theorizing, since it's rooted really, or takes its starting point, contingent facts about the actual world, such, for example, constraints by our actual psychological makeup. Now, feasibility questions take different forms depending on what one takes conceptual engineering to consist in and the targets of conceptual engineering. So I want to talk a little bit about what my approach to conceptual engineering here is. So here I operate with a psychologistic and practical aim understanding of conceptual engineering that has been developed and defended by conceptual engineers such as Isaac, Fisher, Marjorie, and others. And I think it's like a really influential research stream within conceptual engineering right now. Now, in that context, the psychologistic approach can be described as follows. This is a quote from Koch. To engage in conceptual engineering is to advocate and implement changes in how people use words, classify objects around them, and draw inferences about these objects. And this pairs very well with the practical aim approach, according to which conceptual engineers, at least sometimes, aim to change how people think about objects, how they classify them, and how they use words. For example, by getting people to stop calling whales fish or start calling certain acts misogynistic. Okay, so a lot of stage setting, but with that in mind, I can reformulate my main question for this talk. My main question for this talk is, how feasible are conceptual engineering projects of social concepts that operate within a psychologistic, practical aim background and aim for the engineered concept to be widely adopted in ordinary everyday life? Now, my aim for this talk is to argue for 3 claims in response to this question. I'm going to argue that show you that a dominant tradition in social psychology gives rise to a concern for this type of social psychologistic conceptual engineering. The concern is that conceptual engineering efforts of this type are ineffective in promoting conceptual change. Then I argue that this tradition, however, tends to ignore that concepts don't only encode statistical, but also causal information. If we pay attention to this feature of concepts, I argue, we dissolve the initial concern, because this feature of concepts makes, paying attention to this makes clear that conceptual engineering isn't only possible or feasible, but that there's an imperative to conceptually engineer. Okay, so our journey starts with a little detour into the psychology of concepts. Now, again, some clarification. How do I understand concepts here? I'm going to treat the term as describing mental representation of categories that are responsible for our categorization and induction behavior. More concretely, I adopt I adopt a notion of concept that has been defended and worked out in the work of Edward Marjorie, that describes them as individual level psychological entities, specifically bodies of information about acts that are stored in long-term memory and retrieved by default in processes underlying most, if not all, higher cognitive competencies. For example, inductive reasoning, categorization, when these processes result in judgments about X. And by feature, I describe represented properties associated with or constitutive of concepts. Now, many also use the term conception, prefer the term conception to describe these kind of things that I'm describing right now. And if you're one of those, you can you're free to understand this talk as talking about how feasible projects are that change our default conceptions associated with categories. Okay. So a dominant tradition in the psychology of categorization is based on Eleonore Neufeld's influential work on concepts. And a core insight of her work is that, or was and is, that human categorization is not arbitrary, but instead there are fundamental psychological principles that constrain possible systems of classification for all human cultures. And these principles have crucial implications, I say, for theories of categorization and, inter alia, the feasibility of conceptual engineering projects. Okay, so what are those principles? The first principle is the principle of cognitive economy that says that the task of conceptual systems is to provide maximum information with the least cognitive effort. Now, this principle strikes a compromise between two distinct pressures. On the one hand, to get as much information as possible from an act of categorization, while at the other hand, to preserve our limited cognitive resources. Now, from this principle, or like a natural extension of this principle, is that the concepts most useful and basic for us are those that have a high degree of similarity and distinctiveness. Where similarity can be described as the probability that a feature is present given that a category is present. So, for example, the probability that you bark given that you're a dog. And distinctiveness can be described as the probability that a category is present given that a feature is present. So, for example, the probability that you're a dog given that you bark, or that something is a dog given that there's something barks. Now, we here, or in general, features that are similar and or distinct are also abbreviated as typical features. And this view that similar and distinctive features are kind of at the core of our category representations also led to the so-called prototype theory of concepts, which is, in a nutshell, very simplified, the view that we represent categories in terms of typical features. So I want to illustrate why representing categories in terms of similarity and distinctiveness, or via the first principle of categorization, is so useful. Now, imagine kind of possible acts of categorization, such as categorizing something as a dog versus in contrast to categorizing something as a giraffe. Now, if you categorize something as a dog, you can draw many inferences from that act of categorization, simply because category members are very similar to each other. So simply because within category members, categories of the members of the category dog are so similar to each other. So from that act of categorization, categorizing something as a dog, you kind of infer that there's something likely has fur, a tail, 4 legs, is cute, and floppy ears, and so on. But at the same time, you preserve cognitive resources. So if you want to rule out that this thing is a giraffe, you don't have to do a really long feature search, simply because members and non-members of the category dog are very dissimilar to each other. So you don't have to run a really long comparative feature search, as long as you hit a highly distinctive property. As soon as you hit a highly distinctive property, highly diagnostic property, such as barks, there's a pretty high likelihood that this something is a dog. Okay, so this moves us to the second principle, the principle of perceived world structure. And this principle says that the perceived world comes as structured information rather than as arbitrary and unpredictable attitudes. Now, unpacking this, what this principle says is simply that some properties co-occur with other properties more often than with others. And the perceived world reflects those bundles of co-occurring features, can extract structure from that. Now, we can illustrate this in a simple way. So the perceived world, the kind of data bundles that we get, often pair lions with manes. But it so happens that given the kind of world we live in, we very rarely are confronted with these kinds of combinations. Okay. Now, I want to illustrate what the explanatory reach of Russia's principles is, why they're so useful. And in order to illustrate that, she herself points to a fictional animal taxonomy in Celestial Emporium of Benevolent Knowledge by Jorge Luis Borges, where he considers a fictional animal taxonomy in which animals are divided into A, those that belong to the emperor, B, the embalmed ones, C, those that are trained, and so on, M, those that have just broken a flower vase, N, those that resemble flies from a distance, and more. So the question we want to ask is, why this kind of taxonomy doesn't exist, because it is, of course, a possible taxonomy. And the principles, the Russia's principles of categorization explain why we don't carve up the animal world in this way. So consider or suppose that two entities X and Y both resemble flies from a distance. So we classify them under the concept resembling flies from a distance, as in this fictional taxonomy. Now, assuming this classification is correct, what else can you predict about them? Not much, since given the sort of world we live in, X and Y are likely to share only very few additional properties other than looking like flies from a distance. They could be flies or bats or stoats or birds or whatever. So this kind of active categorization doesn't seem very useful. On the other hand, suppose that X and Y both look like lions, so we classify them as lions. Now, again, assuming the classification is correct, what else can we predict about them? Well, lots of things, given the structure of the world we live in, that they probably have a heart, fur, mammals, hunt, and so on. Okay, so we see these kind of two principles of categorization that really have shaped the psychology of concepts and categorization, and the strong explanatory reach of the principles, the wide explanatory reach. But now that we went through the relevant work in psychology, we can ask ourselves, what are the implications of these two principles for conceptual engineering projects? And again, the kind of projects I'm interested in here today. So psychologistic projects that aim at improving our representations of social categories. Okay, so I want to illustrate this with an example. If we treat concepts in this Russian way, and they're kind of empiricist, thin, simple prototypes that more or less mirror the co-occurrences in the perceived world, then we can just consider that here we have taking the example of the concept pit bull, we have certain perceived world patterns that look something like this. And our concept pit bull, the typical features we associate with it, simply reflect or mirror these co-occurrences that we get from the perceived world. So we have typical features such as short coat, muscular, aggressive, and so on. Now, say you are a conceptual engineer about your project, your target is the concept pit bull, and you would like to change it such that instead of aggressive, we now associate the concept with the feature friendly. Now, what would happen assuming the two principles of a categorization are correct? Well, notice that the perceived world patterns stay constant. We don't change the world. So because of that, given the principles and the fact that the perceived patterns stay constant, what we will expect is that the new concept that now encodes friendly will simply revert to the old concept, because one of the principles says, of course, one of the constraints we get from the two principles is that our concepts mirror the structure, mirror the patterns that we get from the perceived world. So we can now see what the principles of categorization mean for the feasibility of certain conceptual engineering projects, assuming that we represent concepts in this empiricist way. So what they mean, or what seems to be a kind of prediction or upshot here, is that novel ordinary concepts, so novel classification and induction proposals, won't be implemented if the real world input we receive aligns better with the old concepts. Therefore, if our ameliorative aim is to change a given classification practice, what an implication of the two principles is that such a change will fail to stick if the new classification system is not exposed to the corresponding data bundles. Now, precisely this general theme or idea of this impasse is actually reflected in much work in psychology. So more broadly, this understanding of concepts as simple prototypes can really be found in a lot of work in social, developmental, and cognitive psychology, and really shapes their theories of social concepts. So here's a quote from a very widely viewed TED Talk by Bloom, in which he says that our ability to stereotype people is not some sort of arbitrary quirk of the mind, but rather it's a specific instance of a more general process, which is that we have experience with things and people in the world that fall into categories, and we can use our experience to make generalizations about novel instances of these categories. Similarly, here's an example from the inventors of the so-called implicit association test, Banerjee and Greenwald, to say similarly that the IAT's effectiveness relies on the fact that your brain has stored years of past experiences that you cannot set aside when you do the IAT sorting task. And lastly, a recent paper by Gabrielle Johnson also redraws on this kind of theme, where she argues that human bias, just as machine bias, is the result of the training data on the basis of which we make predictions, reflecting the slogan, garbage in, garbage out. And from this, she draws, one of the conclusions she draws from this is that this can solve the bolster critical insight from equality advocates that representation matters. Now, that was actually not the last thing. Now it's the last thing. This general thought is actually also reflected in many stereotype intervention efforts, where a lot of cognitive strategies focus on providing counter-stereotypic or non-stereotypic information about group members to undermine or dilute stereotypic association. Again, here we see the principles in action. So the idea is that while a lot of your perceived world patterns about pit bulls have looked like this, in stereotype intervention techniques, we now provide you with input data that rather look like this in the hope of changing your concepts and the typical features you associate with them. But again, what does all this mean for social psychologistic conceptual engineering then? Well, you might think that this leads to a pretty grim conclusion for our capacities of changing social concepts, for the feasibility of changing social concepts, insofar as it seems to be the case that conceptual change can only be implemented via perceived world change, which then suggests that there's no hope that we can engineer better ordinary social concepts, given that the world patterns are fixed. And this would also support some so-called anti-individualist conclusions, according to which we should really stop focusing on minds and concepts, but rather devote our activist efforts into structures and systems, simply changing the real world. Now, there's a really promising approach that has taken this problem seriously and given a really promising solution to this by Eugen Fischer. So recognizing that our stereotypes are really sensitive to the input patterns we get, Fischer has proposed in a paper that we can change our stereotypes in language comprehension contexts by changing the linguistic environment of the lexical term in question. So his idea is that when a linguistic context is incompatible with a certain aspect of the retrieved stereotype, that aspect will simply be inhibited in further processing. So we can just design the context in a way as to inhibit a problematic aspect of a stereotype. When a core stereotype underspecifies a linguistic sense given the context, the stereotype will be enriched. So what's special about these approaches is that there's no change in the stereotype contents that are linked to a given concept or linguistic item per se. Instead, the proposal is certain decisions of how we design the linguistic environment, the environment of a given linguistic item, simply modify the stereotype that influences online linguistic cognition. Now, I think this is a really promising proposal that takes feasibility issues seriously and can help in many contexts, especially linguistic contexts. But I do think there are potential problems with that proposal for the kind of conceptual engineering tasks we are interested in here today in this talk. Because first of all, the proposal as such is restricted to linguistic cognition, but we are interested in conceptual engineering projects that really shape our ordinary deployment of concepts in all sorts of cognitive tasks, all sorts of categorization, induction, reasoning tasks in all sorts of cognitive contexts. Secondly, some conceptual engineers might have the aim to change the very stereotype, not only to engineer the linguistic context around them, so our deployment can kind of be affected, but to change the very stereotype as such. And we still want to ask ourselves, how, if at all, can we achieve this? Because take the pit bull example, the term pit bull will often be employed in contexts where the context won't be incompatible with the stereotype aggressive. So we will still use it. But as conceptual engineers, we might be interested in the question, how can we really change the actual stereotypes, such as to take the typical feature aggressive out of it. And lastly, Fisher himself points to the problem of a so-called control gap, which is that sometimes stereotypes are so salient that they continue to influence linguistic cognition. And this might, of course, extend to many social group concepts as well. And again, we might be especially interested in the question how to change the very stereotype for good, such that this further influencing can't be happening. So with that, we're left with our kind of preliminary worry that conceptual change of the sort we're interested in today can only be implemented via world change, via change of the actual world. And there's really just changing concepts without changing the world is really not feasible. Manipulating conceptual structures in isolation is not feasible. However, in the second part of the talk, I want to give reasons for optimism and argue that discussions of conceptual engineering, stereotypes, implicit bias, machine learning, and so on tend to overlook a key aspect of conceptual structure. And this aspect is that concepts encode causal structures, so relations between features or intuitive theories. And my claim is that conceptual engineers with a psychologistic approach that focus on changing social concepts should focus on these causal structures as a locus for conceptual activism and change. Okay, so let me start by telling you a little bit about causal models. Generally, we can say that the general idea is that our categorization and induction behavior suggests that typical features are not, or features in general, are not only associated with feature weights, with probabilistic weights, but are also represented as causally related. And a big lesson of this paradigm is that the paradigm that focuses only on typical features is incomplete. Now, there are many effects that support the view that concepts encode causal structure. Here's just one influential paradigm that some of you might have heard of, the so-called transformation paradigm that has been developed by Frank Kyle. And in this transformation paradigm, perceptual properties of an object of a particular category are modified as to look and behave like a member of a different category. So here's an example. Children and adults were told that a horse was made to completely look and behave like a zebra through operation and training by doctors. And the task is then to answer the question, is the resulting animal a horse or a zebra? Now, what is often found is that children and adults judge that the perceptual appearance does not affect category membership. A horse stays a horse, even if it looks and behaves like a zebra through, for example, surgical manipulation. Now, the results, these kinds of results have often been taken to support psychological essentialism, which is the view that we represent many categories as having a hidden essence which determines the identity and superficial observable properties of category members. Now, and similarly, these kinds of results have been taken to show that categorizers attribute some unobservable constancy to the animals that isn't affected by superficial observable changes. Now, what's really important is that psychological essentialism is just a version of a causal model theory. And the causal structure underlying essentialism directly explains the judgments we see in the transformation paradigm. So we can imagine essentialist category structures consisting of something like a category essence that is causally connected to a bunch of superficial features. These superficial features, according to causal model calculus, just provide diagnostic evidence for an underlying essence that normally causes the features. But if the superficial features are a result of external intervention, the inference from surface feature to corresponding essence is defeated. Because of that, we continue to rely on the feature we knew was present before the intervention. This effect is also called the undoing effect, and it's a hallmark effect of causal reasoning. Now, something that might be worth pointing out is that we don't have to come up with the causal mini theory for each kind of category we encounter with, but seem to have certain higher order theories, certain templates that we can readily apply to certain domains. For example, natural kinds and social kinds often seem to be associated with a common cause model, such as the one we saw for psychological essentialism. And kind of more generally, it seems to be the case that we are subject to something that in psychology has been called the inherence bias, which is a bias that leads people to overuse intrinsic or inherent features in their explanation. So to illustrate this, consider the pattern of having orange juice in the morning. It seems to be much more natural to accept the following explanation. We have orange juice in the morning because of its nutritional content. So to appeal to an inherent feature, and it seems to be much less natural to accept explanations such as we have orange juice in the morning because of an orange crop surplus in the 20th century, which is rather an external feature explanation. So it seems we have a general bias, a general kind of higher order theory where we are biased to overuse intrinsic or inherent features in our causal models. Now, causal essentialist biases play a role in many aspects of language of thought. According, the literature has appealed to many kind of phenomena such as generic teleological reasoning, the semantics of slurs and other social kind terms, and so on. Now, again, this is just kind of a super quick tour through this literature, but the general lesson seems to be that ordinary concepts don't only encode features and their weights, so distinctiveness and similarity metrics, but also causal relations between the features. Now, you might think like, okay, this is all interesting, but why does this matter? So here's an illustration for why taking seriously the causal and the statistical organization of conceptual structure really matters, especially when we think about social categories. So there's a pervasive and early emerging stereotype that represents men as having more raw brilliance than women. And this kind of stereotype is also highly correlated with gender representation in certain fields. Now, let's say that your concepts, female professor and male professor, encode the features smart and hardworking as typical. Now, if we say so, it's like, identical with respect to their probabilistic weights. Now, if this is the case, does this mean that our concepts are identical in this respect, identical with respect to how the features smartness and hardworking are represented? No, because the same feature weights are compatible with different causal models. For example, the feature smart might be represented as causally dependent on hardworking in female professor, but not in male professor. And empirical work suggests that exactly this is the case, namely that the brilliance bias is not merely a statistical bias, but also a causal bias. So why being successful and smart is thought to be caused by hard work in female professors it depends on innate brilliance in male professors. Now, why does that matter? Because this will have many downstream effects in a lot of behavioral and cognitive contexts. So it will affect the modal compositional profile of the two concepts. Compare, for example, female professor embedded in lazy male professor. So a lazy male professor will likely not be judged to be smart anymore, simply because smartness was dependent on hard work. But the laziness cancels this causal feature. So you make a forward inference and infer that a female professor likely won't be smart anymore, while a lazy male professor can still be smart, because in his case, the smartness was not causally dependent on the hard work. Similarly, it will have effects on our interpretation of evidence and resistance to counterexamples. So, for example, if men are modeled as highly disposed to be good at math, and you find a group of men that is bad at math, you can just keep the original model and add interventions, add auxiliary hypotheses. Finally, it will have a role in the spontaneous explanations we generate. So when we generate explanations for women's performance, we will likely it will be more likely that we refer to hard work rather than brilliance in contexts such as letters of recommendation, teaching evaluations, and so on. Okay, so now we can go back to conceptual engineering and think about what all this means for the prospects and feasibility of conceptual engineering projects of social concepts. Now, recall our first tentative preliminary insight that was the only way to change concepts is via world change. And this kind of preliminary worry was that conceived this way, there's no distinctive role for the conceptual engineer to play when it comes to engineering social concepts. But we now see that there are ways to change concepts without having to change the perceived world patterns, without changing the probabilistic representations or probabilistic weights of our typicality profile, namely by changing the representation of the causal relations between conceptual features. And my proposal is that this is where the core task of psychologistic conceptual engineering of social concepts lies. So what would this look like in practice? In order to see this, let's go back to our example of the pitbull concept and consider these two candidate concepts of the causal model we could associate with the category. So we have one causal model according to which the slide is actually not completely correct. I just changed it and made it worse. But we have one causal model. Okay, just imagine one causal model that is here, where you have an internal pitbull property that directly causes aggressive behavior. Just imagine this like a causal model here. And we have an internal pitbull property that causes aggressive behavior. This is one candidate causal model. Now here's the second one. The second candidate causal model we have is that we have an internal pitbull property that is associated with friendly behavior. However, we have bad owners that causally intervene on this variable and change the value of friendly to aggressive. Okay, so these are our two candidates. This is our second candidate of a causal model associated with pitbull. And the first candidate was a model where we simply have an internal pitbull property that causes aggressive behavior. Okay, we have two different causal models associated with the candidate causal models associated with the concept pitbull. Now, what happens, or why is it important which causal model we adopt? Well, it's really important for many purposes. Imagine you have a causal model where a very simplistic causal model where an internal pitbull property causes aggressive behavior. Let's say this is the model that is just the kind of fault model that is really widely distributed in a given society. And you want to push for certain policy changes. If you have that causal model, what you will push for is, of course, to simply get rid of pit bulls, because there doesn't seem to be really any other way. It's the internal pit bull property that causes aggressive behavior. But what if you push for that policy intervention and this model is the one that better corresponds to reality, is the one that is more accurate? Well, this would mean that your policy intervention will likely be ineffective, since this variable of bad owners, also if you get rid of pit bulls, can simply causally latch on to the behavior of other dogs and intervene on it in the same way. So we will end up with another breed that will be equally aggressive. Okay. So what happens if we start out with the kind of simple causal model in which we have an internal pit bull property that causes aggressive behavior, but want to now conceptually engineer it as to look like this model? Okay. So we start out with our initial pit bull concept. Oh, I should have shown you this. Yeah, we start out with our initial pit bull concept where we have an internal pit bull property that is simply causally related to features such as aggressive and muscular. Now, remember that these features are simply high in typicality and accurately reflect the perceived world patterns we have, where the world patterns look something like this. Now let's say we invest our conceptual engineering efforts as to engineer, change, ameliorate the concept such that it will now look like this. We have an internal pit bull property that is causally related to the typical feature of muscularity. We have another typical feature of aggressiveness that is simply caused by the external feature of bad dog owners. Notice that the perceived world pattern is unchanged. The input we get from the perceived world, the kind of data bundles, remain the same. Now, what is really crucial, the crucial point to note here is that the constancy of the perceived world patterns now won't affect our new pit bull concept. And this is the case because our new causal structure is completely compatible with the probabilistic input we're receiving. Remember, we're still representing the features of aggressiveness and muscularity as typical, as having high probability. Now, the lesson here is that the world pattern, the perceived world pattern, is completely compatible with the new causal model. So although the world pattern and the principles stay the same, the new concept can stick. Again, the lesson is that we now seem to have a way to conceptually engineer concepts to modify conceptual structure without that being sensitive in the same way to perceived world patterns. Now, This, of course, opens up new questions, such as the questions which interventions we should use for changes. Generally, we can say that once the concept is proposed and accepted, we can make a concerted effort to give the evidence for it to affect conceptual changes. But what is really important is that the evidence is more sophisticated than the simple diagnosticity or similarity metrics. The data, the right data, it's kind of misleading to call it data. The right data will be data that use interventions or little experiments that demonstrate kind of experimental interventions that allow people to infer the appropriate causal directions. So interventional evidence would look roughly like this. It's kind of evidence that can be captured by notions of controls, hold the kind of owners fixed across dog breeds. Now, what are the effects on dog behavior? If the proportions are preserved, we have evidence for the inherent causal model, but if the proportions are indistinguishable, we have evidence for the re-engineered causal model. Now, remember, we really appeal to causal notions here, such as control notions, to give people the possibility to infer causal direction, and don't simply appeal to statistical patterns. In order to present this evidence in the most effective way, we will, of course, have to appeal to evidence from the cognitive science of causal reasoning, as, for example, the work by Lagnado, Sloman, and other researchers. Now, I've shown you that conceptual engineering isn't under the same threat, or no threat whatsoever, actually, that we thought it was when we adopted the mainstream approach to social concepts, stereotypes, and bias. I've shown you that we can conceptually engineer in a way that doesn't depend on world change. But now, let's suppose that the world does change in the desired ways, that the probabilistic input we receive from the world reflects much better patterns. So suppose the world changes in many desired ways, such that the probabilistic weights we associate with many features, like, let's say, for example, friendliness in pit bulls, these changes in ways that we would call a big improvement. Now, in this scenario, would we still need conceptual engineering? The answer is yes, because the models that we start out with give us certain inertia. Given that a concept already encodes a certain model, we can always fit the model to the data simply by adding auxiliary hypotheses, by explaining away, and so on. And this is important in many respects. First, because this will prime us, this will make us be primed to find evidence that fits the model. But our model would simultaneously be constantly confirmed, because we don't realize the compatibility of the data with alternative models. And the lesson I end my talk with is that we must engineer. We are left with a stronger claim that conceptual engineering isn't only possible, but it's necessary for certain social cognitive goals. Changing the world here would not be enough. And that's the end of my talk. Thank you very much.